Yeah, so for 2020, the papers had really tough questions on organic. So most of the questions that we'll be doing will be on organic, but I have also selected a few other hard questions so that we can solve them. And then once we do, then of course, I'm sure you wouldn't have any issues with them. So the first thing you should do is make sure that once you solve this class, then go home, or whenever you're free, solve the papers that are remaining. So you should solve 2020 paper 1 for O levels and paper 2 for IGCSE. Paper 2 is important for IGCSE people who are going for extended. Do not solve paper 1. That's really easy, and don't waste your time on that one. Okay, so that's what I would suggest. So just focus on paper 2 for O levels. Hello, Zara. Thank you for joining us. And hello, everybody else. Hello, Arham just joined. All right, so let's get started. Which statement about polymers is correct? All right, so we know polymers are made from small units, which we call monomers. It says nylon and terylene are produced by addition polymerization. Now, the first thing you should know, the moment you see this, you should know that nylon and terylene both have linkages in them. Does anybody recall what's the linkage in nylon? What's the linkage in nylon? If you're still having problems with the polymers, I would suggest go to the YouTube channel. There's a very short, half an hour long video on biochemistry that summarizes everything you're supposed to know about these condensation polymers. And I put a lot of work into that, so make sure that you watch that if you're still having problems with this. So yes,
amide linkage.
Amide linkage is present in nylon. Very good. And Arham, you're right. This is ester linkage in terylene. Now, whenever you get linkage, that shows you can't have addition. Linkage is always produced through condensation. Okay, that is one primary difference in addition and condensation polymers, which means you can't have this statement. Nylon and terylene both contain amide linkage. Again, we just talked about it. For nylon, the statement is correct. Nylon does have amide linkage, but not for terylene, so that's why it won't have that. Simple sugars are produced by hydrolyzing proteins. Wait a minute. What happens to condensation polymers if you hydrolyze them? You're basically adding water again. Acids will be there to help you out. So you use hydrolysis to convert a condensation polymer back into its monomers. So what this statement is saying is that we are able to make simple sugar from protein. What is the monomer of protein? Go on. What's the monomer of protein?
Amino acid.
Amino acid. Very good. Which means that proteins, if you hydrolyze them, they'll convert to amino acids, not sugar. Okay. If something did hydrolyze to sugars, what was that? Carbohydrate. Very good one. Yes. So if something hydrolyzed back to sugars, that must have been carbohydrate. So yeah, this statement is wrong. Starch contains the elements carbon, hydrogen, oxygen. Starch is a carbohydrate, which means that it is going to have carbon, hydrogen, and oxygen. Walid, what did you mean by that sign? I don't know that. What did you mean? Do you want me to revise something that we just talked about? So the answer for this one is D. Moving on. The question shows the structure of a monomer. Which diagram shows the partial structure of its polymer? Okay, so the first thing, whenever you see this, how do you draw polymers for double bonds? So here's what you should do. Write the double bond like that, and here's what you should do. This is your standard structure, okay? Now convert this thing, whatever you have, into this form. So if I look at this carbon, it has a chlorine here, a hydrogen here. If I look at this carbon, it has a fluorine here, and whatever is left over, combine it all. So that's the first thing you should do whenever you look at a double bond being used for polymerization. Convert it to the standard form. Standard form always has double bond in the middle and these things at the top and bottom. Okay, now we are looking for something that has this thing repeated multiple times. How do you do addition polymerization or any polymerization? The mantra is RCJ. What is RCJ? R means remove, C means copy, J means join. Remove, copy, join. What are you removing? You're removing the double bond. What are you copying? You're copying the remaining part. Whatever this is, copy this and then join them. That is the method to make polymers. RCJ, every single time, remove, copy, and join. So look over here, where do we have this? So first of all, what we're seeing is that same carbon is attached to methyl and fluorine, and the other one is attached to chlorine and hydrogen. So just look for that. Yeah.
So can you repeat the RCJ process, the remove?
Yeah, RCJ simply means, so let's suppose I'm starting over here. RCJ says that take the repeating unit, whatever this thing is. Let's suppose ye hai hamare paas. Remove the double bond, copy the remaining part, and join them. And there you go. That's your polymer. In addition polymerization, you remove double bond. In condensation polymerization, you remove a simple thing like H and OH, or H and NH2, or AH and Cl. Although in O levels and IGCSE, we just H and OH. So that's a fairly simple thing. Remove that thing, copy whatever is left, and join them. That's how you make polymers. Okay, remove, copy, join. All right, so we are looking for carbon that is attached to CH3 and fluorine and chlorine and hydrogen. So make sure that that is what you're looking for. For example, in this one, B might be a contender, but the problem is we are looking for CH3 and F. And over here, CH3 is joined with chlorine wala carbon. That's wrong. Same चीजों को join होना चाहिए उसको. Okay? Same चीजों को join होना चाहिए. What that implies is कि अगर मेरे पास ये चीज ऐसे होगी तो ही bond बन सकता है. So look over here. This is CH3 and F. Perfect. This works. ठीक है? This is the only one in which same carbon is attached to CH3 and with F. अगर ये नहीं समझ आ रहा, just look at the second one. Pick the second one. Chlorine and hydrogen. That is what you're looking for. The carbon should be with chlorine and hydrogen. The problem with the first one, chlorine hydrogen तो है, methyl fluorine नहीं है. अच्छा, यहाँ पर fluorine hydrogen है, chlorine hydrogen नहीं है. Chlorine fluorine कर दिया उसने. He's just playing with you. He's switching these things so that you make a mistake. But don't fall for it. Your monomer should be repeated exactly the way it's supposed to be. So for that reason, our answer is going to be D, because it forms H and Cl and F and CH3. So we're going to go with D. All right. What is the name of the ester shown? Again, I told you that whatever is with O, that's the branch. So look over here in the branch. 1, 2, 3. 3 carbons. 3 carbon is prop. If you need a soft copy of this paper, hold on, let me share this in the group. I'll just send it to the group, okay? This is the paper that we are solving. All right, so prop, that is these 3. So there you go. 3 carbons, that's prop. So propyl, that's the branch. So that means it's either B or C. Now look at the second one. 1, 2, 3, 4. Do not make the mistake of not counting this. It's a common mistake. Students are like, oh, this is part of the ester, so I don't need to count them. You do need to count it. So 1, 2, 3, 4. That is 4. That's butyl, which means butanoate. Why noate? Because this is organic salt. I told you, organic salts or esters, they have 8 at the end. Now, I don't expect you guys to not remember meth, heth, prop, but. You should remember this. But in case somebody is still looking for a way to memorize them, or their method, then here's a simple one. Met, eth, prop, but. So one way of remembering this is monkeys eat purple bananas. So monkeys eat, or monkey eats purple bananas. Again, don't, you should remember them anyway, but agar nahi kisi ko yaad, so this might help. But remember that 5 and onwards, they're just like geometry. So 5 means pentagon, 6 means hexagon. Okay, so hexagon में 6 होते हैं, hexyl में भी 6 होंगे, hexanoate में भी 6 होंगे. All right, so just remember that. All right, so we are looking for propyl butanoates or propyl butanate, that's B. Which structure shows the carboxylic acid with lowest relative molecular mass? Okay, first of all, we are looking for carboxylic acid. That's important. Examiners will try to confuse you because if you read this statement, what is going to be your focus? It's really easy to be like, okay, which structure shows the carboxylic acid with lowest relative molecular? Oh, it's easy. I just need to find the lowest MR. Let me calculate the MR of all of that. But you don't need to do that. That's a waste of time because not all of them are acids. So don't just focus on one part of the question. Look at the other one as well. So it's saying it must be a carboxylic acid. What's a carboxylic acid? Anything that has COOH in it. So this is a carboxylic acid. This is a carboxylic acid. These two are. This one is not. This one is not. This one is clearly diol. Diol because it has alcohol on two sides. So diol. So this will not stand. So we are looking for just A and B. And between A and B, we can clearly see that B is a bigger molecule. So it will have a bigger MR. So without any calculation, you can figure out that this is part A. See, you don't have to do any calculation, even if they say find the lowest MR thing or whatever, because you can infer them by analyzing these structures. And it will save you a lot of time. Which organic compound is used as a solvent, a renewable fuel, and in the production of vinegar? Interesting. So we need this thing as a solvent. So alcohols are good solvents. So B or D could be it. A renewable fuel, alcohol, we make it from fermentation and we use it as a fuel, for biofuel. And then in the production of vinegar, does anybody know what's the main component of vinegar? It is ethanoic acid. And the moment somebody sees this, it might be like you're compelled to select A as your answer. But remember, you use ethanol to make ethanoic acid by oxidation. Remember, KMNO4 goes purple to colorless when you oxidize ethanol. So you can convert ethanol to ethanoic acid. Is ethanol used as a solvent? Yes. Is ethanol a renewable fuel? Yes, but ethanoic acid is not. Is propanol a renewable fuel? Yes. But what is used in the production of vinegar? Only B. Of course, A is also used in production of vinegar. Vinegar is not entirely ethanoic acid. You add water, you add a couple of other things. But ethanol is the only one that fulfills all three options, which is why we'll use this one. You might be looking at this small link over here. I use pastmcqs.com to make the papers for MCQs. I really like that website, so I would suggest you go and check it out. All right, which statement about the organic compounds, methane, ethene, and propane is correct? Okay, so wait a minute. Out of these, can you pick the odd one out? Which of these four is the odd one out?
Sir, C2H4.
Very good. And why is that? Why is this odd?
Sir, it is an alkane and the rest are alkanes.
Very good. So this is an alkene. How do we know? Because the hydrogen is double the carbon. If hydrogen is double the carbon, that's alkene. If it is more, it's something else. It could be, if it is that plus 2, It is alkane. If it is that plus one with something else, that could be alcohol, that could be something else. Okay, only C2H4 and C2H6 decolorize bromine water. Wait a minute, bromine water decolorizes because there's a double bond. Every time there's a carbon-carbon double bond, not carbon-oxygen double bond, carbon-carbon double bond, the decolorization happens. So this is a test for unsaturation. So while this is true for this because it is alkene, it is not true for this because it is an alkane. It's a saturated thing, not going to decolorize it. Okay, these are all saturated compounds. Again, this one is not because it has a double bond. These are all unsaturated. Again, no, because. So yeah, the answer is D. Very good, Arsham. Which structure represents an isomer of butane? Now pay attention, guys. We are looking for butane, which means we are looking for 4 carbons that are arranged in some manner, and the formula is C4H10. Okay, that's the formula. All right, now let's see. Which structure represents an isomer of butane? The butane in our syllabus that we know, or in fact, the butane that we draw is C in the long chain, 4 of them. And there you go. Now, how do you identify an isomer? I told you a method. What you do is you pick a pencil, and remember that game where you join all the dots and you can't just come back and all? So do it. 1, 2, 3, 4. I can join 4 carbons here without picking a pencil. Can I do the same thing with the rest of them? 1, 2, 3, 4. I can, right? So not an isomer.
So can you repeat this?
4.
Pencil.
So the method is write the original one and see how many carbons you can join. So you can join 1, 2, 3, 4 without picking a pencil. So if you can do the same thing, it's not an isomer. It's the same thing. So 1, 2, 3, 4. I can still connect 4 without picking a pencil. A and this are the same thing. Okay. 1, 2, 3, 4. These are same thing because I can still join 4 without picking a pencil. Okay, let's do this one. 1, 2, 3, and I can't join the 4th one because I will have to go back, which is not allowed. So I can join 3. Okay, wait a minute. Let me try another way. 1, 2, 3, still 3. 1, 2, 3, still 3. Okay, so I can still join just 3. So this might be an isomer. Okay. Now I will not look at D. Reason. D is C4H8. And this is C4H10. So D is clearly not an isomer. So my answer is C. A and B are butane. They're just differently formed. Examiner is trying to trick you into thinking that B is isomer. It's not. You can rotate molecules all the time. Remember, kinetic theory, molecules are in constant random motion. So when they're moved, it is very much possible for the chains to twist, turn, and all of that. But that does not mean it's an isomer. This is the thing that's an isomer. So if you can join 4 in the same manner without picking a pencil, then that's not the case. Okay?
Sir, B has 5 carbons. So
you're right. It seems like B has 5 carbons. But this is actually a mistake that was corrected later on by the examiner because this was a typo. This was supposed to be hydrogen. But yeah, look, judging by this thing, we can clearly see that these are 5, so not an isomer anyway. So,
yes.
Yeah. Okay, aluminum is produced by electrolysis of pure aluminum oxide. Is that statement correct? Is that what we have studied?
No, sir.
Do we use pure aluminum oxide? We don't. Usually we don't. We add something to aluminum oxide. What is that thing? Cryolite is added. Very good, Ahmed. What are 2 uses of cryolite? It acts as an impurity, so lowers the melting point, sorry, because aluminum oxide is solid. So it lowers the melting point. And what's the second use? The IGCSE people, you need to know this. It acts as a solvent. Okay, cryolite acts as a solvent. You need to remember this. Okay, so this one is saying that we use pure aluminum oxide. ठीक है, मान लेते हैं. One of the electrodes in the process has to be replaced often. Okay, we do know why we need to do that. We talked about this in the last class as well. When you have carbon, carbon does not react at normal temperature, but at high temperature, carbon can react with oxygen. And in this process, you are providing oxygen. You have an oxide which will make oxygen. Now, what kind of ion is oxide? Positive or negative?
Negative.
Negative.
Will
So
go
it
to
will
anode.
go to anode. I'm sorry, Samira, could you repeat that?
I said it'll go to anode.
It will go to anode. Yes, you're absolutely right. Because it's an anion, it will go to the anode. And when it goes to anode, it forms oxygen. That oxygen reacts with carbon. It wouldn't react if this was room temperature, but this is high temperature. You're using an ionic compound. High temperature carbon reacts, makes carbon dioxide. And that is why you have to replace it. Okay, so the product at anode reacts with it. And that is why the answer should be A. Clear? Everybody, pay attention. The product at the anode reacts with the anode. The examiner is trying to trick you by saying, oh, the product at cathode reacts with anode. Bhai, they are so far away. Cathode's product is not going to travel all the way to anode. They're separate. So that's not going to happen. Okay? All right. Which diagram correctly shows the conditions necessary for the rusting of iron and also the metal that can be used to prevent rusting by sacrifice? So they're testing us for two things. Number one, rusting of iron. What are necessary conditions? Tell me.
Presence of
Moisture.
oxygen and water.
Moisture or water, yeah. Second,
Oxygen.
oxygen. Very good. So we need moisture, we need water, and of course we need iron. Second, sacrificial protection. What is the principle of sacrificial protection?
It's
That
basically a
gives
more
you-
reactive metal which is used to protect a less reactive metal.
Very good. So a more reactive metal is used to protect the less reactive metal. That's absolutely right. Anzila, what did you want to say?
The same thing that it leaves itself to protect the other layer.
All right. So can anybody tell me over here, if you look over here, we have magnesium, we have copper, we have iron. Those are the three metals being used. Can you arrange them in order of reactivity? Which one is most reactive?
Magnesium.
Then,
Hmm.
yes, Umar has given us the answer. And Rasham, you're also right. Magnesium, then iron, then copper. Yeah, very good. So that means if I want to do sacrificial protection of iron, then I need to use magnesium. That's one. So that means it's either B or D. And second, I want to prevent it from rusting. So I need a situation where rusting can happen. If there's only oxygen, there's no chance rusting will happen. I don't need this magnesium. Iron itself will stay as it is. And that is why my answer is going to be D. That there is a chance of rusting here, yes. And there will be sacrificial protection because magnesium doesn't react. Okay. Will iron protect copper through sacrificial protection here? It will, because iron is more reactive than copper. But then the second thing is, copper itself won't react with water. So there is no chance copper is going to react with water. Copper can react with oxygen at high temperature, not at low temperature. Can anybody tell me why copper doesn't react with water? Why doesn't copper corrode just like iron is? For that, we have to understand what water is. Water is H and OH. There's the positive ion of hydrogen, there's the negative ion of oxygen when water ionizes. And because copper is less reactive than hydrogen, yeah, Umar, you're right. Because copper is less reactive than hydrogen, copper cannot react with water. It cannot displace it. But iron can displace it, which is why iron does rust. Also, let's suppose magnesium reacts with water and oxygen. Can I say that magnesium has rusted? Turns out we can't say that. We can say that magnesium has corroded. So corrosion is a term that is applied to all metals, but rusting is a term that's only applied to iron. It's a special term for iron only. Okay, which equation shows a thermal decomposition? Again, decomposition reactions, here's the basic structure. You start with something which breaks down into multiple things. That is the idea of decomposition, okay? You start with one thing that breaks into something else. And judging by that, there's only one option, that is C. And yeah, this does happen in the blast furnace. I just picked one word and I was able to find my answer. But other than that, this also happens in blast furnace. Can you tell me the name of this thing?
Calcium carbonate.
Limestone.
Calcium carbonate is the chemical name and limestone is the common name. And this is coming from lime family. Lime family is something you need to know about. There are 4 members of this family. There is limestone, which is calcium carbonate. There is lime itself. There is slaked lime, this thing. And there is lime water. Do not forget the lime family, okay? Now, wait a minute. Aren't slaked lime and lime water the same thing? What's the difference here? The difference is that slaked lime is solid, but lime water is aqueous. Lime water is a saturated solution. Okay, does anybody know what saturated solution are? Saturated solution is a solution that has dissolved all of the solid that could be dissolved. You can't dissolve any more solid in a saturated solution. And we use it. Remember in ATP, we talk about crystallization process, and we always say that heat the thing to saturation point. Basically, we are saying that evaporate all the extra solvent. That saturated solution is important for crystallization. It's slightly different from concentrated because concentrated simply means there's high amount of it. It does not mean that you cannot, in a concentrated solution, you can add more and dissolve more, but in a saturated solution, you can't. If you add something to a saturated solution, it will just stay as it is. It will not dissolve. Okay, so 4 things of lime family. Okay, tell me, what is the use of slaked lime? It is used to fix pH of soil. Both lime and slaked lime are used to do that. So they're used to fix pH of soil. Soil that is overly acidic, you can use these things and convert it to neutral, or if you use more of it, you can convert it to alkaline soil. Okay, and what is the use of lime water?
So for the test of carbon dioxide, to check the presence
Very
of
good.
carbon dioxide.
So lime water is used to test for carbon dioxide. It turns milky when you add carbon dioxide to it. Okay, and limestone is used for construction. It's the main component of marble, and it's also used in blast furnace, as you can clearly see. Okay, does anybody know what this thing is called?
It's calcium silicate, sir.
Calcium silicate, or also called slag. Okay. And this thing is silicon 4 oxide, also called silicon dioxide. What is the structure of silicon dioxide? The structure. The structure is tetrahedral. I'm sorry, Unzila, can you say that again?
Lattice structure.
Any solid has a lattice structure. It is giant lattice. Okay, giant covalent lattice. So all solids have giant structure. Calcium oxide has a giant structure, but that is giant ionic structure. This one is giant covalent. Okay, so you have to make that distinction. All right. Which element can only be extracted from its ore using electrolysis? Wait a minute. How do we extract metals? So for that, you have to remember that we use 2 things for extraction. So let me write the reactivity series. Does anybody recall what that was? Reactivity series. We started potassium. Then, do you have periodic tables with you? Open the periodic tables. Go on right away. Okay, we'll start with group 1. What is above group 1, above potassium? Periodic table, go on. What is above potassium in the periodic table?
Sodium.
Sodium, very good. Now, both of these will be very reactive because they need to lose just 1 electron. But potassium is more reactive because it is bigger. It loses it faster. Okay, now let's go to group 2. What is next to potassium in group 2?
Magnesium.
No, next to potassium.
Oh, calcium.
Calcium, yes, calcium. Calcium is bigger. What is above calcium?
Magnesium.
Magnesium, very good. So calcium and magnesium both need to lose 2 electrons. That is why they will be here right after sodium. But calcium is bigger, so it is more reactive. Okay, now move on to group 3. What is in the second element in group 3?
Aluminium.
Aluminum, that comes next. Okay, and after that you have transition metals. So aluminum, then zinc, then iron, lead, hydrogen, copper, silver. Okay, so that's the transition metal thing, and you don't need to get into why they are arranged this way. Okay, tell me, why is aluminum, even though you can clearly see that aluminum is pretty high in the reactivity series, why is aluminum still considered unreactive?
Because of the oxide layer present.
Yes, because of the oxide layer, which is non-porous. It's always important to mention that oxide layer acts as a barrier or it is non-porous. Don't just say that layer of oxide. Acts as a barrier, which means aluminum atoms cannot react with something. It's a barrier. It doesn't allow them to pass through. Yeah. Okay. Where does carbon fit in? Carbon is right over here. Okay. Now, here's the thing. If you can use something to displace the other one, you will use it, provided it doesn't get very expensive. So the displacement principle says a more reactive thing displaces a less reactive thing. So here's what we do. If I can use hydrogen to extract anything, I will use it because hydrogen is relatively cheap, but copper and silver are expensive. That is why, because hydrogen is more reactive than copper, we use hydrogen to extract copper. We spend hydrogen to gain copper. We spend hydrogen to gain silver. We spend hydrogen to gain gold because they are more expensive than hydrogen. But if we can spend carbon, carbon is dirt cheap. Carbon is really, really cheap. If we can spend carbon, then we will use it and extract the other thing. So I can use carbon to extract iron. Why? Carbon is more reactive. Iron is less reactive. Carbon will go in, put iron out. So I will spend carbon. I will use carbon to extract it. So I can use carbon to take iron out, lead out, hydrogen out, copper out, silver out. We can extract all of these using carbon, but we still use hydrogen for these two because hydrogen is much cleaner. Carbon can get messy, that is why. So we use carbon to extract these. Okay, over here, these can be expensive on their own because it's very difficult to extract that. So what we do is we use electrolysis. Instead of using, I could use calcium to get magnesium out. I could use calcium to get aluminum out. I could do that. But calcium itself is hard to get. That is why we just use electricity for these. Okay. And sorry, zinc should be over here. Yep. So carbon can be used to extract zinc. IGCSE people know about it. You use zinc blend with carbon. Okay, so judging by this, which can we extract using electrolysis? Remember these things, the things above carbon. Why? Because carbon is cheap, but then these things are not. So that is why. All right, so tell me which one. It is calcium. Very good, very good. All right, chlorine is passed into separate samples of aqueous potassium iodide and aqueous potassium bromide. Okay, I have chlorine, I pass it into potassium iodide, and I have chlorine, I pass it into potassium bromide. All right, tell me, again, displacement principle. Will chlorine displace iodine? It will. Obviously, it does. Because chlorine is above iodine in the periodic table. So it is more reactive. For non-metals, things that are higher are more reactive. For metals, things that are lower are more reactive. And we've talked about it in periodic table chapter. If you need to review it, I recently uploaded a video on it on YouTube. Make sure that you watch it if you need to. Okay, so chlorine will displace it. Potassium chloride is formed and iodine is sent out. Over here, potassium chloride is formed again, but bromine is sent out. Okay, what is the color on the left side? Green for both of them because you have chlorine added to it. But on the right side, this will be red, brown, or orange. You can say both of those. And the reason this happens is because there's a reaction. As long as there's a reaction of hydrogen, there will be color change. So do we see color in both? Yes, we do. Okay, can anybody tell me what is the color of potassium iodide?
Yellow-brown?
No. Potassium iodide, because it is made from non-transition element, it will be white as a solid and it will be colorless if you dissolve it in water. But iodine on its own will have a color. So iodine will be blue-black as a solid or brown if you dissolve it in water. Okay? And if you evaporate it, it will be purple, but you don't need to know that. Okay, so it's not required. All right, so moving on. Acha, is this a redox reaction? I haven't balanced it, but is this a redox reaction?
No, sir.
It is. And here's a shortcut. This will really help you out. If there is an element in the equation, that's a redox reaction. It's a very easy way of identifying if something is redox. Is there an element here? Yeah, there is chlorine. There's iodine. So if there is an element, whether it's on the right side or the left side, doesn't matter. As long as there is an element in the equation, it will be redox. So this one is redox because chlorine is losing electron and iodide is gaining electrons. Sorry, chlorine is gaining electrons and iodide is losing electrons. Okay, so this is redox. All right. Which process occurs in the manufacture of sulfuric acid? Okay, sulfuric acid, the step was you take sulfur, you burn it, you get sulfur dioxide. You take sulfur dioxide, you oxidize it. What's the catalyst present? Come on, what's the catalyst present?
Vanadium oxide.
Vanadium 5 oxide.
Very good, vanadium 5 oxide. Then this SO3 reacts with the H2SO4. It produces H2S2O7, which is you're just adding it. It's addition reaction. Addition reaction always produces just one product, as you can see over here. Whether it's organic or inorganic, addition is still the same. And then you add it to water, and this makes 2H2SO4. Okay. We could bypass this and add SO3 directly to water, but the problem with that is that this is an explosive reaction, which means that this will be the last reaction you do in your life if you try to do this. And that's why we first add SO3 to H2SO4, which is concentrated, and then we add water to that. All right, so we have this thing. Let's see, burning sulfur in air. Yes, we are doing that. Dissolving sulfur dioxide in sulfuric acid. Nope, we are using sulfur trioxide in sulfuric acid. So this is not happening. Dissolving sulfur dioxide in water. Nope, not part of this over here. Reacting sulfur dioxide with air. Air has oxygen, so yeah, this is happening. So 4 is happening, 1 is happening. So yes, 1 and 4. Okay. 2 fertilizers are made by mixing chemical compounds. Okay, what are the 3 main elements fertilizers should provide?
NPK.
NPK, yes, very good. Nitrogen, phosphorus, potassium. Okay, 2 fertilizers are made by mixing chemical compounds. One contains 500 grams of ammonium nitrate and 500 grams of ammonium sulfate. Okay, The other contains 700 grams of ammonium nitrate and 300 grams of calcium sulfate per kg. Okay. Which fertilizer contains the higher percentage of nitrogen by mass and which contains the higher percentage of sulfur by mass? काफी लंबा काम लग रहा है ये. No problem. कर लेते हैं. So, what is the total mass of this thing? First, figure out how much is the MR. You already know that. Okay. And how much is the nitrogen? Remember, this thing is giving us 2 nitrogen, so that's 28, 14 times 2. This one's also giving 2 nitrogen, so that is 28. This one's giving 28, and this one is not giving that. Okay. Acha. Next, if I look at nitrogen, this is going to give me 28 over 80 times 500, obviously, because this is 500 grams, plus 28 over 132 times 500. Okay. So technically, I am getting this much mass of nitrogen in the first one. In the second one, I'm getting 28 out of what is ammonium nitrate? 80 into 700. So just figure out which one is higher. Is the top one higher or is the lower one higher? Again, what am I doing here? I'm using percentage mass, but instead of multiplying by 100%, I'm multiplying them by the mass that they have. So, okay, so 28 divided by 80 times 500, ye zyada hai, which is 175. So this is 175. And 28 divided by 80 times 700, ye 245 hai. So I just want to know if this will exceed it. So 28 divided by 132 into 500. So this is going to give me 106 for this. So I'm getting 281 total. Yeah, this one wins. So this one is giving me more nitrogen. Okay, so nitrogen aa gaya X. What about sulfur? Remember, this one is also giving sulfur. This one is also giving sulfur. Nitrate to khatam na. So let's look at sulfur. Sulfur is 32 out of 132 in the first one. And in the second one is 32 out of 136. Multiply this by 500 because वो 500 and multiply this by 300 because वो 300 है. So 32 divided by 132 times 500, that is 121. And 32 divided by 136 into 300, that is 70.6. What a shame. So this one, X is also providing more sulfur. So the answer is A. Okay, so we're done. काफी लंबा सवाल था easy. All right. Which aqueous reagent liberates ammonium from ammonium nitrate? I really like this question when I saw it because it's questioning our idea of what ammonium salts are. Remember, what is ammonium ion? It's very interesting because all ammonium ion is a forced marriage of hydrogen and ammonia. That's it. The situation is that ammonia has bonded with hydrogen ion. Why it does that? That's dative bond. But that I only talk about in my high achievers class. We don't need to go into that. Students who are attempting distinction and all that, unke saath hi baatein karte hain. So no worries, don't worry, you're not missing out on much. All right, so ammonium ion is basically acid that has ammonia trapped in it. So the moment it reacts or it's heated, ammonia goes away. Remember this. What is ammonium? Ammonium is acid with ammonia trapped in it, which means if you heat it, ammonia goes away. If you react it with something that reacts with acid. What reacts with acid? What reacts with acid?
Base or metal.
Base or metal, very good. So you have acid here, so that will react with base or acid, and that way it will convert it and will obviously release ammonia. All right, so that's what happens here. So when you react ammonium with any base, so you're looking for a base here, okay? And there's only one base in your answer. This is potassium hydroxide. So if it were to react with base, it will release ammonia, because what is ammonium? Ammonium is acid with ammonia trapped in it. All right. All right, moving on. Which row correctly shows whether the hydrogen ion concentration and pH of ethanoic acid are lower than those of HCl of the same concentration? We have talked about this in the last exam as well. pH of weak acid is higher, pH of strong acid is lower. Okay. And hydrogen ion concentration, again, same thing. pH is judging the same thing. So if pH is higher, concentration is lower for hydrogen. So higher and lower, that's what we're looking for. So hydrogen ion concentration for ethanoic acid is higher, lower, and pH is higher. So yeah. Okay. Many reactions can be classified as redox. Which reaction shows? अच्छा, मैंने आपको अभी एक shortcut बताया था. Use it and tell me what's redox. Is the first one redox?
Yes.
It is. Why?
There's an element.
Yes, there is an element. There is magnesium. There is hydrogen.
Yeah.
It is clearly redox. What about the second one?
Yes, sir. No.
It is. There is chlorine. And third one, clearly the same thing. Sodium and bromine. So as long as there is an element in the equation, it will be redox. So there you go. Okay, this question is using what we call Avogadro's law. I've talked about Avogadro's law in, I think, the first class that we had. Let's see what the question is saying. A mixture of 5 CM3 CH4. So Avogadro's law, what does it say? It says that mole ratio for gases is same as volume ratio. Okay, so the ratio of volume is same as ratio of moles, which means if I take the 5 CM3 here and everything, the mole ratio and the volume ratio is the same. Okay, so it is saying there is 100 cm3 of air and 5 cm3 of methane. Okay. Assuming air is 80% by nitrogen by volume. So मुझे बताओ, 80% nitrogen by volume, that means it's not going to react. So how much oxygen do I have? I just have 20% oxygen, which means out of 100, I have 20 cm3 oxygen. So 5 cm3 methane and 20 cm3 of oxygen. Okay. Now, there you go. They've told us the resulting mixture is cooled, all volume. It is cooled. It's important to remember that this is cooled. All volumes are measured at room temperature. This is the equation. What's the composition of resulting gas? Okay, here's the thing. What does the question say? Question is telling me 1 mole of methane reacts with 2 moles of oxygen to produce 1 mole of carbon dioxide. So that means if I have 5 of this, it will react with 10 of this and produce 5 of this. Okay. All right, let's see. Do I have 10 cm3 of oxygen? I do. I have more than that. I have 20. Okay, so that means methane is the limiting reactant. That's the first thing you should check. Limiting reactant. What's the limiting reactant? So that's methane. So limiting reactant is completely used up. So methane is completely used up. So I will use 5 cm3 of methane and 10 cm3 of oxygen. Okay, how much carbon dioxide is made? 5. So that is true for all of them. How much oxygen is left? How much oxygen is left over?
10 centimeter cube.
I'm sorry?
10
centimeter
cube.
10 centimeter cube. Very good. So now these two could be an answer. Nitrogen is of course there. And how much of steam is left? Look at the equation and tell me how much steam is left.
Ten centimeter cube.
Look at the equation again. You're right that there was 10 centimeter cube steam made, but none is left. Yes, Arham, you're right. Because look at this word. The resulting mixture was cooled. And if you look in the equation again, water is liquid, which means 10 centimeter cube water was made, steam was made, but then it wasn't left. It was completely used up. So the answer is, B. Okay. There's no steam left over. Okay, this is about definition. The expression shown for the value of AR for fluorine is incomplete. Okay, what is the relative atomic mass? The definition. There's usually the question that comes for this is 2-mark question. And what does it say? Average mass of one atom of that thing. AR is always about atoms. So average mass of one atom, that's 1 mark. And the second one can be a little confusing, but bear with me. Compared with 1/12 of carbon 12. Now, why do we do that? Because we just need a unit, right? For anything that we are measuring, we need a unit. So if you're measuring the mass, we need unit. Unit is 1. So carbon is 12, and if you divide that by 12, you'll get 1. That is why we say it is 1/12 of carbon 12. That's the idea. And that is why we are going to use atom and 1/12. So B is my answer. So this is just a definition. No straightforward concept there. Which substance conducts electricity both when solid and when molten? Wait a minute. The moment you see something conducting a solid, that's metal. Okay. So tell me, out of these 4 options, which one will have a metal? Or which one will have metallic bonding?
An alloy?
Alloys, yes. So alloys are basically metals mixed with something. So they're still mixtures and they still have metallic bonding in them. Okay, so it is an alloy. All right. The diagram shows the relative mass and relative charge of 2 particles present in atoms and ions. Which of these particles are present in hydrogen atom and in hydrogen ion? So let's look over this. Hydrogen atom, that is 1 proton, 1 neutron. 1 proton, 1 electron. Which of these is it? Relative mass. This thing, the black one has a charge negative, so that means this is electron, and the hollow one is, wait a minute, is it proton or is it neutron? Which one?
Neutron,
Which is the charge? Neutron, yes. So it's not proton, it is neutron. So we are looking for neutron and electron. So hydrogen atom has electron. So the black dotted thing is there, but there's no neutrons. So it's going to be C. There you go. There's only one option for this. I don't even need to look at this one. Okay. The diagram shows 2 experiments. What are the results of adding excess NaOH in each experiment? Okay, so what's happening in the first one? You know it's aluminum, and we know aluminum gives white precipitate, and that dissolves, right? White precipitate dissolves. And in the second one, copper, white precipitate doesn't dissolve. Okay? With sodium hydroxide, this is what dissolves. Zach. Zinc, aluminum, chromium. Okay? Zinc, aluminum, chromium. You don't have to remember it that way. 2 main things to remember. So zinc, aluminum, and chromium, they dissolve with sodium hydroxide. And zinc and copper dissolve with ammonium hydroxide. Those are the only ones. So zinc, aluminum, chromium, and zinc and copper. Okay? So there you go. So it's going to be, it does dissolve, it doesn't dissolve. So, yep. Aqueous sodium thiosulfate reacts with acid to make a precipitate of sulfur. This is actually a reaction from A levels. This is a compulsory reaction in A levels, but they're not going to make the question overly difficult. Let's see. A student investigates the effects of temperature on this rate. What's happening? Initially, of course, they have 2 colorless solutions, so they are able to see the crosshair. But after a while, what happens is that this sulfur solid is made. And this sulfur solid will, of course, obscure the cross mark, so you wouldn't be able to see. And secondly, sulfur dioxide gas is coming out. What precaution should you take when you're working with sulfur dioxide? Use a
Wear
mask.
safety.
What safety measures? That's what I'm saying. Use a mask, a gas mask, because sulfur dioxide is acidic. So if you breathe it in, I learned it the hard way. I was working with it one day, and I did an experiment around 9 o'clock in the morning, and for the whole rest of the day, I had such severe headache and nausea and all that. And I was like, wait a minute, what is happening to me? And turns out I had breathed in a lot of sulfur dioxide. So thank God there weren't any permanent effects, at least those that I could tell. So yeah. So what they're doing is places a piece of paper with cross, measures the time taken for cross to no longer be seen because there is obviously sulfur being produced, and repeats the reaction at different temperature. Okay. What apparatus is needed for this investigation? Of course, they're doing it at different temperature. That means they need a thermometer. Number two, they aren't measuring anything else, or should they? They should make sure that the concentration of these two things is the same every time.
So
Because-
time taken. So stopwatch.
So yeah, they need a stopwatch for that, but they're trying to measure the effect of temperature, which means concentration and volume and everything else should be the same. Okay. So what should they use? They should use a thermometer, a stopwatch, and measuring cylinder, because they need to make sure they're adding the same volume every time. Why? Because they are measuring the effect of temperature, not the effect of changing volume. So volume should be the same. All right, burning polymers. Do you still have a few minutes? I just have like 6 or 7 questions left. So burning polymers can cause atmospheric pollution. Okay, which polymer burning could produce nitrogen oxides? There's only one polymer in there that has nitrogen in it. So go on, select it.
Nylon.
Nylon, very good. Yep, nylon. That's the answer because it has amide linkage. The diagram shows the structure of a compound called ethanoic anhydride. Okay, this is something new for us, but that's fine. Judging by this, can you tell me what kind of compound is it? Is it ester? Is it carboxylic? Is it amide? What is it? As you can see,
Ester.
this is ester. Very good. 1 mole of ethanoic anhydride reacts with water to form 2 mole of carboxylic acid only. Of course, because it will break down here. This carboxylic acid reacts with ethanol to form an ester. So what they did is they broke it here. So you're left with this thing. And then this reacts with ethanol. Okay. How many moles of water react with 1 mole of ethanoic anhydride, and what is the structure of the ester? So first of all, you're reacting with ethanol and you are taking this part. How do I know it's this part? Because this is where it breaks down, either here or here, one of the two. In either way, it's going to form this, and that is ethanoic acid, which will be made. Ethanoic acid and ethanol will produce ethyl ethanoate. So ethyl ethanoate is 2 carbons in the branch, 2 carbons left over. 2 carbons in the branch, 2 in the leftover. So it's either B or D. Next, we want to know how many moles of water react with 1 mole of this thing. Now let's try to break it down. If I break the bond here, I get this and I get this. So I can just give it 1 hydrogen and give 1 OH to this thing to make the acid. So as you can see, we just needed 1 hydrogen and 1 OH. So I just 1 mole of water. And for that reason, my answer is going to be B. I need 1 mole of water and I need to react it with these 2 things. And it will produce ethyl ethanoate because alcohol is eth and the carboxylic is also eth. All right, hydrocarbon, this thing will undergo a number of chemical reactions. Wait a minute. The moment I see this, I'm compelled to draw it. And as you can see, this will have a double bond, which tells me this is alkene. This will burn. This will do addition reaction, just like all other alkenes. In which reaction will carbon-carbon single bond be broken? Interesting. They're not asking us about double bond. They're asking about single bond, which means I want to break this thing and this thing completely. And when does that happen? When you do addition, This is addition, this is addition, this is addition. Addition only breaks the second bond. The pi, sorry, you don't know the pi word. Okay, it only breaks the second bond, but only combustion breaks all the carbon-carbon bonds, which means my answer is going to be A. Very interesting question. Read carefully. It says single bond to be broken. Gas X is present in dry air, may contribute to global warming. What is X? Gas X is present in dry air, may contribute to global warming. Can't be carbon monoxide, not a greenhouse gas. Methane is a greenhouse gas, and it can be present in dry air. Vegetative decay of matter, which happens all the time, does produce methane, and this is a greenhouse gas. So my answer is this. But wait a minute. It may contribute. Why is it saying it may contribute? Why not it does contribute? But we don't have to get into that, why that is. Because these two gases, they cause acid rain, and this one also causes depletion of ozone. And of course, if you deplete ozone, and these two cause acid rain, and this one is greenhouse, and this one is toxic, which means it's poison. So only B is the right answer. Okay, the diagram shows the electrolysis of a mixture of these. Okay, electrodes X and Y inert, copper is above. Achha, this is interesting because this is the first time for the last 5 years that they have given us a mixture for electrolytes. Usually they just say one thing or with water. And this time you have 3 things there. You have copper, you have silver, you have aqueous solution, water. And they're saying copper is above silver in the reactivity series. It can be deduced that one is initially deposited at electrode this, which words correctly complete gaps 1 and 2. So you can't go wrong with this if you understand the 2 principles of electrolysis. Again, I've explained them more in my other videos, but the 2 principles, I'll quickly tell you about them. Number 1, reactive anode, if you have it. If you have reactive anode, it will ionize, it will dissolve, it will form ions. And we don't have that here, okay? They're saying they're inert. The second principle is lowest reactivity or least reactive thing, least reactive ion discharges except concentrated halogen, okay? So because of that reason, we can clearly see that the least reactive one should go. Which one is the least reactive? So what ions do we have? Let's see. We have silver ion, nitrate ion, copper ion, nitrate ion again. I don't need to write it twice. And then because of water, I will have H positive and OH negative. Now tell me guys, in the positive ones, which is the least reactive?
Silver.
Silver, very good. So because silver is the least reactive, that is the one that's going to be discharged, and that's the one that's going to be deposited. But where would it be deposited? X or Y?
Y.
Why, sir?
Y. Because Y is cathode, it's negative. So yeah, silver is deposited on Y, and that's why my answer is going to be D. Question 29. The equation shows the production of iron by the reduction of iron 3 oxide. This is redox, they've clearly mentioned, and we already have an iron here. 80 tons of iron 3 oxide produces 50 tons of iron. What's the percentage yield? Okay, so this is a yield question. Here's a link to a secret video that I haven't released to people, and that will really, really clear your doubts about, or if you need to go look into how to solve questions on yield. So just hold on, I'll share the link with you. I can't find the recording for now, but I will send the link to you, don't worry. Okay. Yeah, found it. So I'll share the link in the group. So don't share it with other people. This is just for this class, but that will help you out how to solve this. And it's a pretty short 5-minute video telling you about yield and everything. All right, aluminum chloride is dissolved in water and the resulting solution is divided between 3 test tubes. Okay, so I have aluminum. And what do I know about aluminum ion? I know that the aluminum ion, when you add sodium hydroxide, produces white precipitate. When you add ammonia, it also produces white precipitate, both of them white because it's not transient. But it dissolves in sodium hydroxide, doesn't dissolve in ammonia. Okay, so it is part of, so in the first one, it is going to dissolve, zinc, aluminum, chromium dissolve. And in the second one, only zinc and copper dissolve. So that's why this aluminum is going to give a white precipitate dissolving in sodium hydroxide, white precipitate not dissolving in ammonium hydroxide. That's what I know about aluminum. About chloride, what I know is that chloride is halogen. For halogens, remember this thing. It is silver nitrate that is used to test. For halogen, it's silver nitrate. For sulfate, it's barium nitrate. Just make that connection in your mind. You can't go wrong with this. So we use silver nitrate. With chlorine, it will give us white precipitate. So silver chloride is white. Silver iodide is yellow. So that's why you will get, with iodide, if this was aluminum iodide, you would get yellow precipitate. All right, so in test tube 1, they added sodium hydroxide. In test tube 2, they added aqueous ammonia. Okay. In test tube 3, they should add silver nitrate, but they should add silver nitrate with nitric acid. Why do we add nitric acid? We want to destroy carbonates. Again, I can't go into a lot of detail over here. If you need a lesson on this, just give me a shout out or a message and I'll send you the link for that class. So yeah, there you go. So you need to add nitric acid and silver nitrate. You need to add aqueous. So yeah, the answer is D. Okay, so there you go. This was the paper for today. And you should be able to solve all the questions for 2020 papers now. Make sure that you attempt them today, tomorrow, before your mock exam on Saturday. And if you have any questions whatsoever, whether you think it's a silly question, if you think it's a silly question, that's all the more reason to ask it. Because it's important that now, बिल्कुल भी शर्म नहीं खानी है, पढ़ना है और सवाल पूछने हैं. जैसा मर्जी सवाल है पूछें. Ask in the group and I will try my best to help you out. And of course, we have a good community here to help you out. You will have a mock exam on Saturday as well as on Sunday. If somebody wants to come to the campus, I have 2 campuses in Lahore. One is on Jail Road, one is on in Y Block DHA. So you can go over there. Just give me a heads up if you're going, so I tell the staff over there that you're coming. But for the rest of the people who are not in Lahore and can't come, or they're outside of Pakistan or outside of Lahore, then you can do the exam online. Make sure you time yourself and attempt that. Don't delay it, okay? You will get 24 hours to do the paper, and after that, the link will expire. All right, so I'll see you in the next class. If you did not get some notification, then just send them the email IDs. They're collecting email IDs for the Zoom channel thing. So just send the email IDs over there. All right, so yeah, any questions?